Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 4, Lesson 6 and 7, which is called Comparing Relations and Functions. Really, again, kind of a continuation of what we've been talking about as far as identifying functions, what's the difference between a relation and a function, those types of things. And so we want to be able to identify if something is a function in several different ways. We're going to look at graphs, tables, equations. So being able to identify from those different formats if something is a function or not. So in our first set of examples here, I just have 3 graphs. And just by looking at them, we want to be able to tell, is this a function or just a relation? So function or not a function. And if you remember when we talked about graphs, we said that we could use the vertical line test. So I'm just going to make myself a little vertical line here. All right, and so for it to be a function, if I drag it across, remember we said it shouldn't touch more than one point at a time. And so you can see on this oval here, I'm always hitting 2 different points when I cross that. So that tells me that that one is not a function. So my second one, so not a function. Here with this one, as I drag it across, my line's a little bit thick here, but you're going to notice it's really just hitting one point at a time. Everywhere we go, you know, that function is changing directions, but it's never going straight up and down. And so that one, that vertical line test tells me that is a function. And then my last one here, and you can probably tell already, when I drag my line across there, it's hitting multiple points at a time. Here it's hitting more than one point at a time. And so that one is not a function. We're going to have input values that have more than one output value. So another way you could think of it is, say when x is 2, well, I have a y value here. I also have a y value here. All right, so then next one we want to look at are some tables. And so we've talked about with a table, if we have an input value, it can only have exactly one output value for it to be a function. Well, if you look at this one here, when x is 1, f of x, or our output, is 2, it can also be 4. When x is 2, our output can be 3. It could also be 5. So that tells us, sorry about my handwriting here, that is not a function because each input doesn't have exactly one output. With our second table, now I do have inputs that repeat. When x is 1, they've listed that twice here, but notice the output is 2 both times. So it's still just one output for that input of 1. And the same with 2, an output of 5 both times. So even though they've listed the inputs more than once, it still has exactly one output that goes with that input. And so that tells me that this would be considered a function. All right, and then our last examples here are looking at some equations. And there's a few different ways that we could identify from the equation whether it is a function or not a function. So remember, x is our inputs, y is our outputs. One thing that we could try is we could create a table of values, and I could plug in values for x, see what I get for values of y. Am I ever going to have 2 different outputs for an input? And so when y equals x squared plus 1, well, I can plug in, if I plug in a value for x, I'm always going to get just one value for y. If I plug in 1 squared plus 1 is going to be 2, and so on. So this one's a function, and We're going to graph these as well just so we can see it that way too. But I'm never going to get more than one value of y for an x value. Now in this one, it's a little bit harder to see here. And so since we have a y squared, one thing that we could do with the equation is we could solve it for y and see what happens when we have the same setup where y equals. Well, if we want this to be solved for y, we would need to take the square root of that y squared. And if I do that on one side, I have to do that on the other. And so when I do that, the square root of y squared is y. The square root of x plus 1, if you remember, when we take the square root of something that has a variable, or when we take the square root, it could be a positive or it could be a negative of that value. So, the square root of 9 could be either positive 3 or negative 3. And so in this case, if I plug in a value for x, I could get a positive value for y, I could get a negative value for y. So that's a case where I'm going to be getting two different outputs for an input. So this is not a function. But let's look at what those graphs look like. So I'm going to bring up my Desmos here. And so my first function that we said, or first one that we said was a function, was y equals x squared plus 1. Well, if I look at that graph, and I'm going to go ahead and put a vertical line in here that we can use to drag across. Notice it's always crossing at just one point. And we could pull our graph up. It keeps going and going. We're never going to have more than one output for each input, for each x value. Now with our second equation though, that one was y squared equals x plus 1. Well, look what happens now when we drag this across. Now we're hitting 2 points every time, and that's what we were seeing when we took that square root. We were getting the positive of it or the negative of it. And so every input has two outputs here once we get past that little vertex point there. And so there's kind of the visual of seeing that would be not a function. So if you ever are solving and you have that plus or minus with the x, that's telling you you're going to have more than one output. That's not going to be a function. All right, and that's all I have for you guys. I appreciate you taking the time to watch the video. If you have questions, please let me know. Thanks. Have a great day.